problem 9.2. Of course, I've done 9.1 here. And we take a look at it, and what we're trying to do here is determine how confident we are if we take a sample, or to what degree off from the sample might we expect a population mean to be. Okay, and this is probably, when you listen to the polls that we're going through an election cycle, when you hear, so-and-so is up by 2%, plus or minus 3 or something like that, right? Okay, that's that kind of margin of error, and this is really what they're talking about there. So when you hear that, you'll kind of have a better idea of how that works. And so in our case, problem 1, it says sample of 49 observations is taken from the normal population with a standard deviation of 10. The sample mean is 55. Determine the 99% confidence interval for the population mean. So we've got a formula in there, and you go back, it's on page, one of those prior pages there, right? There it is, page 284, kind of right in the middle, right? Doesn't really tell us the variable that we're looking for, but it just says that our x, or sample mean, x with the little deal over it. I probably couldn't figure out how to do an x with a little deal, but our sample mean then is 55 plus or minus, okay, this formula then, our z times the standard deviation divided by the square root of n, or the size of the sample. I kind of have it represented both as the size of the sample, s, and the n, which is the size of the sample. Okay, so in our case then, we know, again, we input our information. Our n is equal to 49. Our standard deviation is 10. That's given to us. And the sample mean is 55. And so we want to know with 99% confidence between what numbers will the population mean fall, okay, based on our sample mean. And so 99% is given, right? That's given to us, and I've got that listed as a decimal, and that's fine. You can put it in as a percentage, either one. So how do we do that? Well, let's just do our formula, right? We know our standard deviation is 10. Okay, our n is 49. Okay, so I've kind of taken and divided it up here. I did the square root first. This is equal to my n to the, okay, and then this is equal to B2, or my standard deviation, because that's already given, divided by this, right? So equal to my standard deviation divided by my square root of n, okay? And then multiply that times my z value. Well, where do I get my z value? I have that written here, but where do we get that, okay? It's that same thing of the standard distribution, and it's on page 732, or of course I've got it represented here, and it can be just as easy sometimes to look it up here, okay? So what we want to do then in this normal distribution is find really from this point to this point, so that I got 99% in the middle covered, and it doesn't let me do that. That's one of the shortcomings, I guess, of this thing, is I can't do the in between, and have it say 90%. So that'd be kind of tough anyhow, I suppose. But what I got to do then, okay, and what you'll need to do on yours is 95%, but I have to divide my 99% in half, and 99 divided by 2 is going to be 49.5, right? Percent, 49.5, or 0.495. Okay, and so I have to, I've got to start from my middle, and I'm looking for that. I'm looking at the big numbers there. It says 45.99 now, but I got to go to 49.5. Okay, and again, this is going to be this gets to be kind of dicey here, trying to get this thing. There's 49.49. 49.52, and that's as close as I can get. And so I'm actually a little bit closer here if I go, right, 49.49. I'm 1/100th off, and my z is 257. Now I know that my z on this side would be the same. It's just be minus, right? Okay, so my z is 257. I can look it up down here too. This is one of those that might actually be easier just to look up down here. What you're looking for then is just 0.495 in this mess here, right? So you just kind of 49494849494951. So 257. If I really wanted to get official, I could say 2575. That would be even more accurate than what I have, but 257 should be fine. So I put that in there as my z value, and I simply say then that this is equal to my z times my standard deviation divided by the square root of n. Okay, so 3.67143, but I want to know between 99% sure between what two figures then my population mean will lie, and so it's plus or minus, right? It's x, or standard mean, or sample mean, I'm sorry. So it's x plus or minus this number, right? So this is simply just saying that this is equal to my sample mean plus, and then this one's equal to my sample mean minus. And yeah, I need to put both of them on there, and so there's my answers. I'm 99% confident that the population mean would fall between 58 and 2/3 roughly, and 51 1/3. And there you have it, problem 9-2.